Hello, hi doctor. I wish your day full with happiness. So today I'm going to share with you what is heat equation and parabolic equation. So in mathematics and physics, the heat equation is a certain partial differential equation. The solution of the heat equation are sometimes known as caloric functions. So the theory of the heat equation was first developed by Joseph Fourier in 1822 for the purpose of modeling how a quantity such as heat diffuses through a given region. So what is the parabolic equation? Parabolic equation, any of a class of partial differential equation arising in the mathematical analysis of diffusion phenomena, as in the heating of a slab. So the simplest such equation in one dimension, which is uxx equals to ut, governs the temperature distribution at the various points along a thin route from moment to the moment.
Next, we proceed to question on heat equation. The question is, the temperature U xt of a long, thin rod of constant cross-section conducting material is governed by the one-dimensional heat equation. If heat is generated in the material, for example, by resistance to current, the heat equation becomes partial U over partial T equals to partial squared U over partial x squared. Given range 0 less than x less than L and 0 less than T, where L is length of the rod.
Suppose that length of rod is equal to 1 meter. One end of the rod is kept at 0 degrees Celsius, one other kept at constant temperature, and the initial temperature given is ux0 equal to half x. So we need to approximate the temperature distribution with h equal to 0.2 k 0.01 at t equal to 0.05 by using 4-point explicit scheme. Now, let's solve the problem. The question have given to us the initial condition and the boundary conditions. So, for the second boundary condition, it's a little bit confusing, but it's okay. Since we know the length of the rod, so we just substitute the length of the rod, which is 1 meter, to the second boundary condition, which it will become u1t equal to 2t. In this part, we will just focus to find this 4 point that highlight by the pink color, which will be known by using the initial condition. In this graph, as you can see, k is the increment of t, which is equal to 0.01, and h is the increment for x, which is 0.2. To calculate the point highlighted before, the pink color, we just need to substitute using the initial condition. So, we just equal t to 0 since it's initial condition, following by x 0.2 and until 0.8. So, we will get the value as displayed and we just insert into the.
Next, I will explain about how to find the value for the point by using boundary condition, which is represented by the blue color point. From these measures, we only focus at the left and right measures. By using boundary condition, we will use this equation u0t is equal to 0, where t is more than 0. Then, we will get the value of u when x is equal to 0.00. And also, u1t is equal to 2t, where t is more than 0. Then, we will get the value of u when x is equal to 1.0. By using the boundary condition, the values we get is displayed in the box, which are when x equal to 0, the value of u00 until u05, all of them get 0. It is because the boundary condition when x equal to 0 is 0. While when x equal to 1, the value of u50 is 0. u51 is 0.02, u52 is 0.04, u53 is 0.06, u54 is 0.08, u55 is 0.1. Because of we use boundary condition, u1t is equal to 2t. So, the value of the point by using boundary condition is shown as the table.
I'm going to explain on how to find the value for the unknown point by using 4-point explicit method. First of all, we have to find the formula of the 4-point explicit scheme for this problem. So, this is the general formula of the 4-point explicit scheme. In this case, We have to find the value of R first. In order to find the value of R, we are required to use this formula, which is R equals to K over H squared. Based on the problem statement, we know that the value of K is 0.01 and the value of H is 0.2. After substituting this known value into the formula, we get the value of R, which is 0.25. Now, we can substitute the value of R into the formula of the 4-point explicit scheme. Thus, the formula for the 4-point explicit method for this particular problem is this. From this formula, let us find the value of U11 at t equals to 0.01. If we compare between U, M, and plus 1 and U11, M is equals to 1 and N plus 1 is equals to 1. Thus, we can see that for U11, the value of M is 1 while the value of N is 0. By substituting the value of M and N into the 4-point explicit scheme formula, we will get this equation. If you see, in order to find the value of U11, it's involving U00, U10, and U20. From the diagram, these 4 points can be connected to form a triangle. These patterns will apply to all of the unknown points all along the solution that using this 4-point explicit scheme formula for this problem. By using 4-point explicit scheme at t equals to 0.01, we can find the value of U11. We have already found the value of U00 by using the boundary condition, while the value of U10 and U20 is found by using initial condition before this. We just have to substitute the value into this formula and we will get 0.1. Next, let us find the value of U21 at t equals to 0.01 where the value of M is 2 and the value of N is 0. By using 4-point explicit scheme, in order to find the value of U21, it will involve these other 3 points below it that can be illustrated into a triangle. The value of U10, U20, and U30 has already found by using the initial condition. So, we can just substitute the value into the formula and relatively, we will get 0.2. The same method applies to the other 2 unknown points at t equals to 0.01. After the calculation, the value of U31 is 0.3 and the value of U41 is 0.275. Next, let's find the value for U12 at t equals to 0.02 where the value of M is 1 and the value of N is 1. Based on the illustrated triangle, the other 3 points that involved in this formula is U01, U11, and U21. The value of U01 has been found by using the boundary condition, while the value of U11 and U21 has been found by using the 4-point explicit method before this. Now, we can substitute the value into this formula and we will get 0.1. Same method apply when we need to find the value of U22, U32, and U42. We have to find all the values of each point until t equals to 0.05 based on the problem statement. The complete values are shown in the following table.
Wait, before we end, here are some applications of heat flow we use in our daily life. That's all. Thank you for watching.